Now I'd like to tell you about the Mongostat command. The Mongostat command is a performance tuning command, and it is somewhat similar to the iostat command from the Unix world, if you're familiar with that. What it will do is it will sample the database in 1 second increments and give you a bunch of information about what is going on during that 1 second. For instance, it'll give you the number of inserts, queries, updates, and deletes. It'll also give you different information depending on whether you're running Wired Tiger or mmap v1 as a storage engine. So let's take a look at Mongostat in a running database. Now, I've got both storage engines currently running on this computer, both Wired Tiger and mmap v1. And I'm currently creating the student collection, which is 1 million students, 10 classes for each student, so 10 million documents. And that's going on in parallel for both the Wired Tiger and the mmap v1 storage engine. Two different MongoDs. And one of them is running at 27017 and the other one's running at 27018. So if I wanted to see how it's going, I could run Mongo, use the school database, and then count the number of students that are currently here. And we can see there's about 850,000 in this one. And if I wanted to see what's going on in the Wired Tiger one, which is running at 27018, I could do that as well. And you can see there are 793,000 students in that one. And every time I run it, that number will be a little bit higher because it's actually running a script in the background. Now, if I want to look at this and see what's happening, I can run Mongostat, and I'll run it without a port number, which will run it against 27017. And if I do that, you can see a bunch of data, and unfortunately, it's wrapping on the screen, so it's a little hard to read. But you can see the number of inserts, queries, updates, and deletes. And you can see that for the 27017 server, which is the default port server, I'm running about 4,000 inserts every second. And there's a bunch of other information here that we'll go over in a moment. Now, if I want to then look at the other storage engine, I could do that. And you can see that that's also running about 4,000 inserts per second. Now let's stress it just a little bit further. So it's running this large insert script that's going to insert all of these different student records. But now let's also run this. So I've written a small script called stressstudents.py, and it doesn't do much. What it does is it goes through and looks in the range of 400,000 to 500,000, and it tries to look up the student by student ID, and there is an index on student ID for this collection on both storage engines. And every 1,000 or so, it just says I did 1,000 searches. So let's run that. And while we're running that, let's go back. And now, once again, let's run Mongostat. And now we see the results are slightly different. We can see that not only are we doing some inserts, and actually the insert rate has now gone down to about 3,000 per second, but we're also doing a bunch of queries. We're doing about 3,000 or 4,000 queries per second. So you can see how this data changes depending on the workload of the database. All right, so let's go over a few more of these different columns and talk about what they do. I'm not going to go through all of them. Insert, query, update, and delete are just these different query operations and deletions, and those are pretty obvious. Get more is how many get more commands we're running every second. Get more is the way you get more from a cursor if you're doing a query that has a large result. All right, this is the number of commands that are running per second, things like create index and get indexes. These are commands. I'm not going to talk about flushes. It has to do with the number of times that it flushes out to disk per second, but I'm not going to talk too much about it. Mapped is the amount of mapped memory that exists in the mmap v1 storage engine. You can see we're mapping a lot of memory, but you can see that we only have about 4.2 gigabytes resident. This is the number of page faults that we're causing every second. And that's an important number in mmap v1 because page faults mean that you're getting more I/O, and more I/O means a slower database. All right. Now, finally, this right here, and these are all wrapped. It's hard to read these. But these are the queue lengths for a number of sockets, I believe, that are waiting, or requests that are waiting for read and for write. And this is the number of active readers and active writers. And then this is the amount that was sent into the database and out of the database during this time frame. Now let's run Mongostat for the Wired Tiger storage engine and look at the differences. Now again, WiredTiger is running at 27018 port, so let me connect to it there. Now you can see for the WiredTiger storage engine, I'm not seeing any queries because I'm not running that stress test against the WiredTiger storage engine. If I wanted to change that and run it against the WiredTiger storage engine, I could do that. Let's change that stress test.py to connect to 27018, and now let's run that. So now we're going to run that, and then while we're running that, we're going to run our Mongostat against 27018. Let's do that. Great. All right. So I'll let that run a little bit, then I'll stop it. All right, so the first thing you notice is that the WiredTiger storage engine is actually managing a few more reads. We're getting reads in the 5,000 range per second, while we're still doing about 4,000 inserts per second. So we're seeing better performance out of the WiredTiger storage engine. This is not the best performance test. I've got two different MongoDB servers running on the same box, but it is an interesting stat nonetheless. Now you'll notice here that we still have this get more column and we have this command column. But then we have a bunch of different columns. First of all, the mmap column is gone because we're not mapping memory anymore. Instead, we have the percentage dirty and the percentage used. And this refers to the percentage of the WiredTiger cache that is dirty, meaning that it's written and will need to be written back to disk if we want to reuse the space. And the percentage used is the percentage of total cache size that we're using. And you can see that that's 10%. And that very little of this cache is dirty. And then we can see that we have about 1.6 gigabyte resonant in the storage engine, and then the queue lengths are again very close to 0, and the active clients are, it says 1, maybe 2 is Mongostat attaching to it, I'm not sure, or potentially maybe that's our stress test actually. It could be our stress test connecting to it. Now let's see, in terms of the resonant size, I'm just going to go back and see what this was. The resonant size before an mmap was 4.2 gigs, and the resonant size here was 1.6 gigs, so it looks like the resonant size is a lot smaller on WiredTiger. All right, so that gives you sort of a taste of what these stats are. Now, obviously, you're most interested in the stats that indicate both the usage of the database and also how much I/O you're doing. And for the mmap v1 storage engine, the number of page faults is a pretty good indicator of the amount of I/O you're doing. Of course, you could also find that out from IOstat. And for the WiredTiger storage engine, I don't see anything that's a clear indicator of the amount of I/O you're doing, although you can tell by the percentage of your cache that you're using how close you are to seeing some pressure on that cache. Obviously, if you're not using the whole cache, you're probably not seeing very much pressure at all on its size. Now, if you want to find out more about Mongostat, of course, the best way to do that is by looking in the manual. And right here, I'm just Googling Mongostat MongoDB. And if I look here, the first link tells me all about Mongostat. I know it's a little bit small here. These are the command line options to run it. I'm not going to get into that. And then finally at the bottom, we've got the fields, which pretty much follow along with what I just talked about, telling you the number of inserts, queries, updates per second that are happening, and then explaining some of the more esoteric ones and which ones also exist only for WiredTiger or what they mean in WiredTiger versus in mmap. So for instance, flushes has a different meaning in WiredTiger versus mmap. Dirty, as I said, is a WiredTiger only term. It's about percentage of the cache that's dirty. Mapped is an mmap v1 storage term. Size is actually, I didn't see a size output. I saw a vsize output, which is why I haven't talked about it. The documentation seems to be slightly off with respect to this column, and I filed a ticket, so you might see this as changed or more clear when you watch this video. Resonant is the amount of resonant memory used in both cases, and faults, of course, is an mmap v1 concept. All right. So those are the major parts of the Mongostat command. And you should use the Mongostat command if you're curious what the database is doing. So that's Mongostat. Okay, now it's time for a quiz on Mongostat. Which of the following statements about Mongostat output are true? Check all that apply. The mmap column field appears for all storage engines. The get more column concerns the number of requests per time interval to get additional data from a cursor. Only the WiredTiger storage engine reports the resident memory size of the database. The faults column appears only in the mmap v1 output. And by default, Mongostat provides information in 100 millisecond increments.